Welcome to this session on Hybrid BSO Storage Mode and how it is revolutionizing the performance in Oracle Cloud EPM. In this video, we will see how Hybrid BSO combines the procedural power of classic BSO with ASO-like high-speed aggregation. The key idea is we stop storing pre-aggregated sparse data, but we still keep all our complex business rules and write back at level 0. For years, we live in two worlds, that is BSO for complex business rules and ASO for fast reporting. Hybrid BSO bridges the gap. It gives us procedural power of BSO but with instant aggregation of ASO. So in simple terms, it's a BSO cube but with most of the physical blocks removed from the upper level. To make this concrete, we will walk through Excel style examples. So think of it as uh, taking what you already do in spreadsheets, like store leaf data and calculate the parent on the fly, and applying that directly inside a BSO cube using a hybrid engine. So for this slide, let's compare traditional BSO with hybrid BSO directly. So in traditional BSO, sparse parents usually must be stored. That means if we have an entity or product parents, when we run the batch, roll-up batch, which uses the scripts like AGG or CalcDim to populate those upper level totals, every parent combination potentially creates an extra blocks. So the block count is high and the memory footprint will be very large. But in hybrid BSO, those same sparse parents can be flagged as dynamic calc. So aggregation happens at retrieval time, not during the batch rollups. So only level 0 data needs to be stored. So the block count drops dramatically and overall database becomes much smaller. So Oracle's own benchmark shows an example where 90 GB cube shrank to 11 GB. It's roughly around 88% of reduction just by redesigning for hybrid and removing the stored sparse aggregations. So let me take you through an example in an Excel just to show the difference between the BSO and hybrid BSO. So in BSO, the parent members, whichever has been highlighted in blue in color, its data storage will be store. Whereas same in hybrid BSO can be tagged as dynamic calc. So how exactly it make a difference? So in BSO, since it is a store, it has to be calculated forcefully by using calc all or AGG or calc dim, right? Which are all the aggregation functions. So once we run this script, all this parent level data will be calculated. Whereas same is not the case in hybrid BSO. Since it's marked as dynamic calc, it calculates as an one request from the user through a smart view or through one report. All right. So and now if I change the value of entity 101, so ideally we expect the parent should get updated, right? So if I make it to 20, if you have observed, the hybrid BSO got updated, but not the BSO, because BSO is a type store which needs to be aggregated or updated manually. So we need to run this aggregation scripts every time there is a change in the data, right? So which will create a block for each and every parent member where the memory footprint will be very large. So in this way, we can clearly mention that the most of the physical blocks are removed in the upper levels in hybrid BSO. So this is a pictorial representation, what has been just explained. So if we see the traditional BSO, since it's a sparse parent, it has created blocks for each and every member, including the parent members, because it's all stored. But same thing is not the case in hybrid BSO. Since it's dynamic, The block is not created, but it is calculated on the fly, right? So this is a traditional BSO where the parent stored in the lower level. So level 3, level 2, level 1, everything has created a block at the respective levels. But same, it's not the case in hybrid BSO. It's only generated when as per the user access on the fly. So it is a dynamic calc, no blocks get generated, and there won't be any index or addressing to this. So when it is addressed, it will calculate on the fly and we get the result on an ad hoc basis. Now let's look into the sparse dimension behavior. First, zero storage for parents. So what exactly it means? When sparse parents are set to dynamic calc, they hold no stored block at all. As soon as we tag the parent member as dynamic calc, it doesn't create any blocks. Okay, there will be a zero storage for all the parent level members, which is tagged as dynamic calc. The index for a sparse dimension points only to level 0 data blocks in this case. Since the blocks exist only for the level 0 members where it stores the data, only for those members the index will be created. So which keeps the index compact and it reduces the input output or the parsing time. Second, it's a dynamic indexing. Because the index is small and the engine understands that parents are dynamic, retrieval from sparse parents becomes extremely fast because we'll be having only blocks for level 0 members only, not for the parent members, right? So since we don't have a block for parents members, the index size will be very small. So if you have a small index, the retrieval process will be very fast because the memory has to parse only few indexes or the few for loops to get the data dynamically. So it behaves very similar to an ASO cube. Like when we use a query like parent like total entity or a total product, hybrid reads only the necessary leaf block and aggregates them on the fly. So let's see an example in an Excel. Since all these parents are marked as dynamic calc, when I have a request like I need uh, for account 1 for product 1, I need to know what is the value for Europe, right? So once I give this access or once I checking this combination in my smart view, it only aggregates Europe on the fly. That is internally it adds up and give me the value as 40. Since it is calculating on the fly, we don't need to create a block for this. So this is how the hybrid BSO works, which keeps the index compact. So on this slide, we'll highlight how block counts and performance change between traditional and hybrid BSO. Let's take an example where we have 100 members in our entity dimension and product has 50 members, both defined as sparse dimensions. So the potential sparse grid will be 100 into 50, that is 5000 combinations. So first let's see what happens in the traditional BSO. In traditional BSO, if parents are stored, will end up with blocks not just for level 0 entities and products but also for the parent combinations. So with a dense dimension layout that encourages the block creation, we can easily approach the full 5000 blocks or more because storing parents causes extra blocks to be created. Like for example, let me take an example. So if I have account 1, okay, and this is a level 0 of entity 101, this will create one block. In traditional BSO, entity parent also will create block for the same account because the parent is marked as store, right? That's what it's been defined. So with the dimension layout that encourages block creation, we can easily approach all 5000 blocks or more than that because the parent is of type store, which will create a extra block, right? So in hybrid BSO, we design so that only the level 0 sparse members are stored. That means we may have around 100 blocks or similarly small number. It only calculates blocks if there is a data because only the leaf entity or product combinations that have data actually creates a block. The total at parent level, that is region or total entity or total product, are purely dynamic at query time. So if we see this example, so we have entity 1 to 5 which rolls up to total entity, and since it's marked as dynamic, this will be calculated on the fly. Even the total product, since it is marked as dynamic in hybrid BSO, all the totals will be calculated on the fly. And whatever we saw in the slide, the same thing has been explained in a pictorial form. So if you see in a traditional BSO, if all the blocks are generated or all the blocks are created, whether it has data or not, when we do the aggregation, all the blocks will be created, which will increase the index size as well. So based on that, our performance of the application will get or will have a major impact. Whereas in hybrid BSO, other than the level 0, all the upper level members is dynamic cal. Is- So it calculates based on the user request or on the fly. So on the standard Oracle EPM financial module implementation, where this approach leads to a large size reduction and faster backup, restructure, and maintenance window. So finally, let's summarize the best practice when designing for hybrid BSO. First is the sole order. In hybrid, need to use the sole order to control calculation precedence. So if a member formula depends on dynamic parents, give that formula a higher sole order so that it calculates after the dynamic aggregation is completed. Think of it like controlling the sequence of formulas in Excel. So hybrid needs to know which formula should be evaluated last. For example, here we have profit equals sales minus COGS, right? And we have a margin percentage as well, which depends on the value of profit because we are using profit divided by sales. Here, if we maintain the sole order same, that is 0 and 0, which is a default value, both will get executed at the same time. So we may not get the value if initially if the profit value is 0, my margin percentage will be blank, right? Will be 0. So when it calculates, if my sales is 100 minus COGS, ideally my profit will be 50. But since both are executing in parallel, it takes the value what was present in profit, that is 0. So my margin percentage will be 0 at the first run. So if I change the sole order, if I change profit, the sole order as uh, 1, and then the sole order as 2 for margin percentage, the first, the profit uh, member formula will get calculated and I'll get the value as 50. So once the profit order is done, since the sole order is 2 for margin percentage, next the margin percentage will calculate and it will be 50 divided by 100. So that will be the percentage for the margin percent. So this is why the sole order plays a very vital role and decide which formula needs to be executed or evaluated first and which need to be evaluated at the last. Next comes the fix statement. So we need to avoid fixing on dynamic sparse parent in calculation script or rules, because fixing on dynamic parent can drag unnecessary intersections into the calc, right? Because since the block will not be present for the dynamic parent, it pulls unnecessary intersections into the calc. So instead of fixing instead of fixing on a dynamic parent, we need to fix on the stored level 0 members, or carefully selected on the stored parent. So the idea is only calculate where we actually store the data. Next comes the member formula. Keep the sparse parent formula simple and avoid heavy cross dimension logic at the parent level. S- So as shown in the Excel, this is the member formula. So if we give a heavy cross dimension, like for cox, I need at uh, once all at year total, all total entity, and total product, and we can also give at prior year December. So all these cross dimension, heavy cross dimension functionalities need to be avoided because it takes more time. It slows down the hybrid engine and it defeats the performance gains. So we need to move the complex logic to a dedicated calculation rule. Next comes the sparse dynamic as a default mindset. The default mindset in new Oracle EPM application should be any level 0 members should be stored. Most of the sparse parents should be tagged as dynamic calc. So hybrid is now the standard in new EPM implementations. So mastering these patterns positions you to lead modern planning Essbase project. Yeah. So thank you for watching this session on hybrid BSO storage mode in Oracle Cloud EPM. So today we explored how hybrid BSO combines the best capabilities of traditional BSO and ASO, giving us the flexibility of procedural calculation along with high-speed dynamic aggregations. So in this session, we covered the difference between traditional BSO and hybrid BSO, how sparse dynamic calculation reduces the block creation, why hybrid dramatically improves cube size, retrieval performance, and maintenance windows, and finally, the key best practices every EPM developer and Essbase administrator should follow when designing hybrid applications. So, the biggest takeaway in this session is store only what truly needs to be stored at level 0 and let hybrid dynamically calculates the rest. So, this modern design approach not only improves the performance but also creates scalable, efficient, and future ready EPM applications. So, in the next video, we will cover exploring advanced Oracle EPM and Essbase concept with practical examples, calculation strategies, groovy scripting, and real world implementation technique. If you found this session useful, please like the video, share it with your EPM community, and subscribe to the channel for more Oracle EPM Cloud and Essbase technical deep dives. Thanks again for watching, and I will see you in the next session.